Question number 6 is a hypothesis test question. But remember, we have already done two Poisson distribution. That means we now have to start doing some binomial distribution in the question. So this is clearly a binomial distribution. In a manufacturing process, 25% of articles are thought to be defective. So we have a percentage, a probability. Articles are produced in batches of 20. So when we have articles, we think of n, so n equals to 20. And when we think about the probability of the article to be defective, so p equals to 0.25. So that's how it works. So the first thing we can do is step by step. Step 1 is to write down the hypothesis statement. A batch is selected at random using 5% significant level. Find the critical region. We don't have to test, we have to find the random variable. Remember, that's the opposite of hypothesis testing. Here we know the significant level, we have to use it to find the random variable. For two-tailed means not equal to. Remember that. So if an article chosen at random for defective is 0.25, which is the probability of success, and that's how it works. Let's start. So H naught, the probability is 25%, so that is going to be 0.25. And since it is two-tailed, it is going to be not equals to 0.25. Now let's define the distribution. Distribution is going to be number of articles that are defective, and the distribution is going to be n is 20 and p is 0.25. Now the next thing we have to determine is the random variables, obviously the critical region that we have to find. So let the critical values be A and B. So this is what's going to happen. So if this is A, so one of the critical region would be less than or equal to A, and the other critical region is going to be greater than or equal to A. Now remember, the significant level is 5%, so we have to break it down into 2.5% and 2.5%. So they have already mentioned this over here, that take each significant level to be 0.025. So what we have to do first of all is write down the first one. For random variable is less than or equals to A, and that is equals to 2.5% means 0.025. So we have to look up the table, the binomial distribution table, and we have to find what is the value of A. So therefore, probability of X is less than or equals to what, and what do we get? So this is the binomial distribution table, and we need n equals to 20. So n equals to 20 is, if we scroll down over here, so this is n equals to 20, and the probability of success has to be 0.25. So 0.25 is this column over here. So if we, so this is going to be 0.25, and we are looking for the probability as less equals to 0.025. So 0.024 is the closest we can get. So it's going to be 1. So let's get back. So we can write probability of X is less than or equals to 1 is 0.0243. So this is the first random variable. So therefore A equals to 1. We found the value of A. Now we have to find the second one. So we can write and probability of X is greater than or equals to B equals to 0.025. So remember, this is discrete. So 1 minus probability of X is less than or equals to, it would be just 1 less than the previous one. Think about this. If it was X is greater than or equals to 10, we would write 1 minus probability of X is less than or equals to 9, 1 less. So similarly, if this is B minus 1. So this would be 0.025. So we can write minus probability of X is less than or equals to B minus 1 equals to 0.025 minus 1, and that would be minus X is less than or equals to B minus 1. 1 minus 0.025 is minus 0.975. If we cancel the negative sign, it would be x is less than or equals to b minus 1, 0.975. Let's go back to the table. So we're looking for 0.975. So closest to 0.975 has to be this one. This is 0.9861 and this is 0.99. So 0.975 has to be this one, 9. So 0.9861. So 9861. So b minus 1 equals to 9, therefore b equals to 10. So the question is, do we have to find the critical values, the critical region? We have to find the critical region, meaning inequality. So the critical region is x is less than or equals to 1 or x is greater than or equals to 10. Question number B. So question number B is going to be another hypothesis test question. Probably this is going to be testing. The previous one was critical region. So what we have over here is the manufacturer changes the production process to try to reduce. So reduce, that means it is going to be less than of defective articles. She then chooses a batch of random and discovers there are 3 defective articles. So the random variable is going to be 3. Test at 5% significant level whether or not there is evidence that the changes to the process have reduced the percentage of defective articles. State your hypothesis clearly. So let's do this. So this is going to be H naught is going to be P equals to 0.25. Remember, we always write the original value of the probability that is given. And H1, this time it is going to be reduced. So it is going to be less than 0.25. So previously we used the distribution X. Now we are going to use the same distribution because the number of articles is still 20. Nothing has changed. So since we have defined it before, we don't have to define it all over again. So that's it. This time we know the random variable is 3 defective articles. Random variable is number of articles that are defective. So what we can do is we have to combine these two, equal to and less than. So this would be x is less than or equals to 3. Now we can look up the table. Okay, so we are looking for random variable 3 this time, and we are looking for the column. Now be very careful in the exam. Use a scale to find out what is the column of the probability. So we're looking for 3 less than or equals to 3. The probability is 0.2252. So 0.2252 is the probability. Now we have to compare this with a significant level, which is 5%. Since 0.2252 is greater than the significant level, which is 0.05, so what we do, we accept H naught and we try to write it as reject. So since we accept H naught, we fail to reject H naught. Hence, write the conclusion in context. There is evidence to believe that by reducing the number, the manufacturer changes the production. So by changing the production, the defective articles are not reduced.